All right, Blaze, are you seeing my screen?
I am. Thank you.
All right, ladies and gentlemen, let's get back to it. Thanks all. Okay, so in my lab, I have an Azure Firewall in the hub. I have 3 spoke VNets. I have an on-prem situation here going through an express route circuit. And what I'm going to do is I'm going to set up routing in this topology to ensure that the Azure Firewall is basically my single point of security for this. So I'm going to draw on-prem traffic into the Azure Firewall as it goes into Azure, into my hub and spoke, and secure it that way. I'm also going to draw traffic from the hub through the firewall so that I have basically an IDMZ. So as hub talks to spoke, I'm secured that way. And also from spoke to hub. And then finally, I'm going to draw traffic from one spoke and hairpin into the Azure Firewall in the hub and secure a spoke to spoke conversation. So in other words, and I'm going to make these marks and then erase, we have traffic coming from on-prem untrusted into the Azure Firewall. It's then again, it's going to sanitize it based on network rules and ACLs that we have, and then allow a transit motion from on-prem into workloads in the spoke. So that's one really important workflow through the Azure Firewall. Then I actually have a route set up here in this subnet, which for today is my jumpbox subnet. So I've repurposed it. And this route is going to draw jumpbox traffic this way into the firewall, sanitize it, and then move it here into spokes. So we're going to see that happening. So that's a second motion. And then we have this idea of spoke to spoke security through the firewall. So untrusted coming into the firewall this way, traffic being sanitized, and then moving to a spoke and then back again. So in this way, I have kind of comprehensive end-to-end security. Another really interesting thing that we have to see today on the Azure Firewall is that it's capable of public NAT and port forwarding, which means that on its public IP out here, sorry about that, guys. On the public IP out here, I can set up NAT rules and port forwarding rules such that public traffic can come in, and I'm going to demonstrate that today from an internet-based source or another public-based source, hit this public IP, and then be essentially forwarded in. And what we're going to do is just SSH into a jump box. So, it's not super esoteric, but it's good to see and good to know how that works. All right. One final thing that's going on in this lab that I'm going to talk about today to demonstrate the application filtering capabilities of the Azure Firewall is how to use service endpoints to basically secure PaaS resources for this topology, and do some really interesting things like allow for private access to PaaS endpoints from on-prem. Now, this story isn't fully comprehensive, and what I mean to say there is that today the Azure Firewall provides application security for an outbound play for HTTP and HTTPS targets. Now, a lot of PaaS instances understand HTTPS, and that's the protocol that they want to use for interaction, Blob being a great example. So we're going to see Blob in action today. Other ones, like Azure SQL, don't use 443. They use, say, 1433. Now, this functionality is being built into the Azure Firewall, so we can have a comprehensive motion. So basically, Secure SQL will be a part of the application suite. That's not here today. Since we are in a public forum today and we have both Microsoft employees and we have customers and partners, we're not going to get too far into the roadmap discussion. Just know that we're working on that, and stay tuned for further updates. So it's not an end-to-end solution quite yet for all of your service endpoint enabled paths, but it will be. That's the big picture. Okay, so why is this important? Why do I want the Azure Firewall to handle service endpoints for me? Well, first of all, service endpoints, as most of us know, is a really cool way to get traffic securely out of a VNet to a PaaS instance, meaning that service endpoints will provide high priority routes that are injected into that subnet that give that subnet basically a better path than quote unquote internet to get out to these service endpoint targets. And when a virtual machine or any other IaaS workload talks to a PaaS resource from Azure, we need to know that it really isn't going over the internet as such in this way and hairpinning back to Azure, right? It's crossing over Azure Dark Fiber. The rub there is that you usually have to set a network security group or other firewall policy to allow internet traffic out, because these PaaS targets are not known to Azure other than Quad 0, right? They're basically summed up as a default gateway, and they're not, from a routing perspective, individualized as discrete services. Well, Service Endpoint solves that. So what happens is that these ranges that are particular specific host-based ranges, there could be a dozen of them or 24 of them per region for these services, become injected as a routing table, or rather a kind of an automatic UDR into these whitelisted subnets, so that we have now a more specific path through Azure Dark Fiber to the service you want that isn't understood as internet. And that gives us the ability to basically move that traffic out of the VNet without having to open an ACL to the internet for it. So service endpoints is really important. What's also important about service endpoints is that in the standard motion, it requires an accompanying feature called service tags in a network security group. And that's not often discussed, and that's why I want to bring it up here. If you're not using, say, the Azure Firewall to do your ACLing, and you're just using a network security group, if you enable service endpoints, that's the routing portion. You also need to account for the whitelisting, blacklisting, network security group portion, and there are always accompanying service tags that would whitelist your destination path targets that would match the service endpoints that you've enabled. So that's an important piece. But with the Azure Firewall, we don't need to do that, and that's an important piece. In fact, what's going on in my lab is that I do have network security groups in these spokes to account for security within a VNet, right? From across and up and down through my VNet as I have different service tiers in there collaborating. But with the Azure Firewall as the central hub for security, my network security group management footprint goes down drastically. So what I've done is there's no NSG in the Azure Firewall subnet. We know from here that that's not necessary. And these NSGs just have very basic rules that apply for intra-VNet security. And when it comes to security rules for, say, spoke to on-prem, or spoke to spoke, or spoke to hub, I don't need any NSGs for that because it's all being drawn into my Azure Firewall through routes and handled there. So that centralized management piece is really critical. And also, of course, the service endpoints, what I'm doing is I am having the ability to sanitize outbound application traffic from spokes into this private IP of the firewall. For blob, for example, let's say that this... Sorry, guys, that's just part of my daily job. People pay me. Let's say that this particular virtual machine here wants to have a connection not to its data disk, which is a separate path, a non-VNet path, but to a blob that I've exposed to upload or download some files, right? It's going to need to talk ultimately to an FQDN that leads to a public IP address. Well, I don't want any public activity coming and going out of the secure VNet, right? That's a security zone for me. So I'm going to route it using a route table. Here's this quad zero route, which is going to draw all public traffic or non-other matching specific traffic out of this spoke, destined to the internal load balancer of the firewall. The firewall then have a service endpoint policy and an application rule to understand that blob target and will forward. Now, service endpoints will automatically translate the private IP of the Azure Firewall node to a public IP that the PaaS instance will understand and handle the response as well. And then what I can do is go down into my other VNets here, and as you see, I've locked down service endpoints, meaning I don't want them turned on, because the only place that I want service endpoints enabled is in my firewall, because I want all auditing and control there. So I want to see who's banging on it, and I want to see who's connecting to what endpoint and not. So if you consider that being a great way to secure not only Azure PaaS motion, but any other HTTPS outbound internet target, you kind of understand the value here. Now, another really interesting thing is that, remember, this is considered an outbound motion. The Azure Firewall today doesn't have an inbound security policy for application stuff, say like an IDS or IPS piece would, or the Azure WAF would. The Azure WAF is a separate product, and we'll talk about that later. That means that if I have untrusted traffic inbound coming in to the Azure Firewall, rather kind of be this way, right, to the Azure Firewall public IP, and I need to say inspect application policy on that and see if that application call is a good call and do SQL injection and that kind of thing. The Azure Firewall doesn't yet understand that. It's looking for application filtering untrusted coming in on this private IP as a quote-unquote outbound motion. Well, that's all fine and dandy, because what's neat is when I have another private block that is injected into my VNet over BGP using ExpressRoute in this case, the Azure Firewall just sees that as another VNet. It considers it an outbound motion because it is a native VNet route that's in there via a BGP route, and this private IP can talk to this private IP and ultimately talk to this blob. And that does that's SQL. That was pretty funny. Talk to this blob right here. And that's pretty powerful because instead of having to talk to this blob publicly over the internet, I can use service endpoints. I can then create a private target here and really lock down that blob to just that one FQDN, that one potential blob that I want this particular target to talk to. And we will take a look at that in depth. It's a really neat architecture. Okay. So that being said, let's take a look at this Azure Firewall in the lab and how my setup is basically built. I'll go through most of the key components to show you in the Azure portal how I arrived at this architecture here for this play. Okay, so here's my Azure Firewall. I just built it last night. Just so you guys know, it's $1.25 an hour, as Yair discussed. If you do some quick math, that's $30 a day for the utility cost. And again, I do believe it's $30 a terabyte out and $30 a terabyte in. Okay, so that's the utility billing component of the Azure Firewall. It is an auto-scale piece. It will auto-scale and fill the entire subnet that you provide it to acquire whatever performance it needs. That's all managed by Azure, by us. So customers don't necessarily need to go in there and twist knobs. It has internal settings on when its CPUs get up to X amount of percent busy. It's just going to automatically build another node for you. And when that cools down, it's going to automatically fold it up. This is not part of the end user visible experience. It's not supposed to be exposed. It's simply an elastic scale motion. So it's just a pay by the drink. It gets as big as you need it to get. And then it also shrinks down to an economical size when it's not busy to save you money, right? So that's the piece there. All right, so as we've talked about, the Azure Firewall is really good at helping you manage your network security groups because it can be a centralized control point for traffic. So how do I get traffic in and out of this thing to achieve that outcome? I'm going to use routing tables. So let's look at what these routing tables need to look like to accomplish what I'm showing you today in the lab. The routing tables are here. All right, so Exhibit A, the first thing I need is a routing table such that any on-prem traffic from ExpressRoute destined to hub or spoke targets in Azure, instead of going directly to those IaaS workloads through the standard Azure BGP motion, they need to first hairpin or take a first stop in through the firewall. So what I have to do is, we see here, is I have to set a route right here in the gateway subnet to point the destinations of these spokes, like 10.116 and 10.132, to the internal IP address of the Azure Firewall, which is an internal load balancer, basically, in front of a big VM scale set. So this is what that looks like. So we go to route tables. Here is the route table for my US West 2 hub, on-prem to firewall. And what I've done here is set up a couple of destination prefixes for these targets that I want to secure through the firewall. This is a jump box subnet. This is another subnet in my hub that has some Nginx proxies in it. Here are my spokes, 10.116, 10.132, and 10.148, right? So instead of the conversation going natively to those endpoints, we only see a whiteboard. Okay, I'll pause again. Let me go to the... Blaze, let me unmute you. Blaze, are you seeing my screen? I'm still getting some conversations that screen sharing is not working.
I'm seeing your whiteboard, and I saw your Azure portal, and then you flip back to the whiteboard, and I see the whiteboard now.
Okay, thanks, guys. Let me clean that up. All right, Blaze, how we doing? We back?
It says loading. Loading.
Okay.
And now we see Skype share, and behind it is your Azure portal.
Okay. All right, guys. I think we're all caught up. Thanks, everyone. Appreciate the support. If things get wonky again, just let me know. Everyone's helping out here. Okay, so we were discussing the route that we need to get traffic from an on-prem express route motion into the Azure Firewall. And this is what that would look like, where these destination address prefixes are subnets, effectively, or VNet blocks that exist in Azure. And instead of having a default motion, I am pointing them as a next hop to that internal IP address of the firewall. All right, so another route that's really important is, remember, I also had a security policy saying, hey, when my jump box needs to talk to a spoke, I would like it to go through the firewall. And that route is here. Basically, those IDMZ spaces in my hub that I want to secure through the Azure Firewall. And also an eDMZ, meaning that anytime anything in my hub, like my jump box, wants to talk out to the internet, go to the firewall. When my jump box wants to talk to on-prem, go to the firewall. And when it needs to go to spoke 2 and spoke 1, go to the firewall. In this case, we'll add in spoke 3 later, and we'll kind of do a workflow there. Okay, and then finally, I need some spoke routes. So let's take a look at what that would look like. So what's going on in the spoke route? Let's talk about that. Okay, here's my default catch-all. That just means anything that's non-specific, my default gateway in the spoke, a public address or a non-matching private address, needs to go to the firewall right here. That's going to get it basically capture any spoke-to-spoke traffic, because remember, a spoke VNet in a standard scenario doesn't see other spokes through the hub. It only sees hub. So that quad 0 will match address blocks of other spokes. So I really just have a really quick summary there. That's all I need. Now, if I want symmetrical traffic between hub and spoke to go through the firewall, and generally I do because this firewall is stateful, I also need to have a route back to the hub from the spoke, because remember, spoke will see hub. So the hub a VNet block is already in the spoke's routing table as a system routing table type VNet. So I have to match it in a UDR or tie it to have a different outcome. And that's what I've done here. So I've said, hey, that hub that you normally see as a regular system route, don't go back through the system routing table, go through the firewall to do so. And then here, this is my on-prem block. So because I have on-prem coming into my firewall, I need on-prem going out through my firewall as well. Now, Yair put up an interesting point on the last discussion we had, which is one of the recommendations is to just go into this routing table and do something called disable BGP propagation, so that you don't have to tie or match on-prem BGP blocks going through the firewall. I'm getting more conversation about the screen sharing not working. Blaze, how are we doing?
I'm seeing your Azure portal.
All right.
Keeping up.
So, ladies and gentlemen, yeah, just Blaze, if it dive bombs, Blaze, just chime in, okay? You'll be my wingman on that. Otherwise, I'm just going to present here so we have a flow. For other folks, I'm really sorry if you can't see the Skype session. Try dropping and rejoining again. I'm actually in a Microsoft corporate office, so I'm using corporate network. So I tried everything I could to make this a good experience. Okay, so we were talking about Yair's discussion of, hey, maybe you can go into a routing table for this and disable BGP propagation, and this way the on-prem blocks that are coming in through BGP, you don't have to match them or tie them, and this quad 0 will effectively do a catch-all for you for all of that. That's a good strategy. That works if you want to see on-prem as a fully untrusted destination. Another strategy is, hey, not all of my on-prem is untrusted. Some of it is trusted and some of it isn't. And in that case, you have this idea where some on-prem conversations needs to go through the firewall as a untrusted motion, and some needs to go around the firewall straight to the express route gateway as a trusted motion. So in that case, disabling BGP propagation doesn't work because it's a one-size-fits-all approach. So what I need to do is allow BGP routes to flow into my hub and then transitly into my spoke, and then start tying those untrusted blocks to put them through the firewall. And in this case, that's what I've done. Okay, so that's a bit of the routing scenario there. Now what we're going to do is look at the rules I have on my Azure Firewall, and then we're going to poke on them. We'll have a discussion about that. So folks, I am getting some additional comments that maybe screen sharing isn't working for folks. I promise this will be recorded, so if you're having a poor video experience today, no worries. The recording will be posted onto YouTube and Channel 9, and we'll get you those links as soon as possible. So appreciate you hanging in there. Okay, so the Azure Firewall basically has three kinds of rule sets today. It has a NAT rule collection, a network rule collection, and an application rule collection. They are processed in that order. Thus, if I have a network rule collection, for example, that would blacklist an incoming connection based on a source or destination, that rule will fire first and would preclude any application rule collection on that flow. Meaning if I'm dumping it at a 5-tuple level and dropping the packet, then the application rule that I'm expecting to match in that packet won't fire because the network rule takes precedence. Same with the NAT. The NAT is the first rule basically to be processed. And as I mentioned earlier, NAT today is just supported on the public IP. So here's an example of that. Internal IP support is forthcoming, but again, we're not really doing a lot of roadmap discussion today. So basically, I've just said that my source address is the public IP address of my on-prem NAT, because this is all an internet-based conversation. The destination address in this case is the public IP of your Azure Firewall. Okay, it's not the actual destination address of the host behind the firewall yet. The destination port in this case is 2201. Why am I doing that? A couple of reasons. One is that right now we're still working out getting the actual destination port of 22 to work as a port forwarding mechanism, and it has to do with the control plane of Azure that needs 22 for its own purposes. So that will be resolved, and you could use 22 in the near future. To me, that's not a big deal breaker or a problem insofar as when I'm doing port forwarding as a network administrator or security administrator, I'm not ever really going to use the vanilla destination port and expose that to the internet because I probably have multiple workstations behind that NAT that I want to SSH to, and I can only use 22 as a destination port once on the first one. And so by and large, the typical motion through the industry has always been use a kind of a related higher order port and then start marching it forward to help me understand which workstations I'm using. So I would have 2202, 2203 on the outside, that kind of thing. Look, it's all grumpy at me. It's funny. It's obviously trying to help me figure out the values I can put in there. Okay, so in this case, I'm mapping 2201 on the outside to my jump box, and of course, this is the IP address that I'm actually interested in hitting in Azure, and I'm getting into 22 there. All right, so let's take a look at that working, because hey, the proof is in the pudding, as they say. Okay, so here is my PC is in the Equinix Cloud Exchange Fabric. And so we're actually coming in from basically the Seattle Weston location, and we're hitting resources over Express Route in US West 2. So there I am. I'm pinging the IP address of my firewall from the Equinix location. And what we're going to do, let me show IP config. Just you guys, just keep me honest here, so everyone knows what's happening. Okay, great. So as you can see, here's that host address. That's my private block, and here is my lab emulated firewall NAT, which is basically just a public IP on this other NIC here. But that services to give me two paths for testing and doing interesting things. Okay. So I'm going to load up my SSH rule for my jump box. Notice how, of course, I've used that higher order port in my SSH terminal, and then, of course, here's the public IP of my Azure Firewall. Now we should NAT through. All right, and we're in. So that is pretty cool. Now, if I wanted to ping on-prem, that probably would not work because the Azure Firewall is a default denied device. So I've set up my routing essentially and cleverly to make sure that I'm drawing all those security zones into the firewall. And then the firewall will basically just drop anything that isn't whitelisted, which is a great and standard security posture, right? Just basically trust no one, and then start building these whitelists about selective trust relationships about who you want to let through and why and how. Okay, so if we wanted to ping on-prem, we could go in and add that rule, but we have some other rules to kind of play with as well. So that's just a quick and easy example of how NAT works for you. All right, let's look at some other stuff. Okay, I'm going to bail out of here. All right, moving on to the network rule collection. This is more of the familiar 5-tuple stateful stuff that would map to, kind of what an NSG is doing. Notice we do have a priority here, so it matters just the way it would in NSG. So let's look at a jumpbox to spoke 1 collection here. So what I'm doing is, remember, it's all default deny, but I'm drawing all this traffic in via routes, and I'm selectively whitelisting those things that I want to get across through my network rule. So I'm allowing ping, say in this case, to my spoke 1. I'm going to allow SSH, and then I'm going to allow, just as another straw man rule, some web. So I was up way late last night trying to install Apache on my web server and just gave up the ghost. Sorry, guys. But we'll look at ping and SSH and get an idea of what's going on. Not that as Apache's hard to install. I was just up too late. Okay, so we're in my jump box. Let's ping that host and spoke 1 through the firewall. All right. Now, to make sure that this really is, this ping is really being received, we actually want to see these packets go through the firewall, right? So let's see if we can do this. This is me challenging the demo gods here. Hold on. See if I can get another session going. Just duplicate this. And then we'll see that SSH going. You'll see what I'm up to in a minute. Okay, so now I'm going to SSH into this guy through the firewall, through that other network rule that's allowing that. Great, so now I'm up SSHing in through my firewall into the spoken back, and if we just do this, okay, oh right. You know what's funny? It's been so long since I've done this stuff. Okay, back to my support days. Okay. Okay, there we go, right? You see the ping coming in. So that's, we have total symmetric ping going across the firewall, and that is an example of that cool network rule working, and the routes working to draw traffic from hub to spoke and back for secure access. So that's pretty cool. All right, let's take a look at the third echelon of security, which is that outbound application play. Oh, we have time. Let's do this. My time check is good. Okay, so let's look at adding a new network rule and how that would work. So, for example, I have a third spoke. Let's pull that back up. And I have a workstation here that I want to ping. But right now, I'm not going to be able to do that because I don't have the necessary implementation. So let me step you through how to do that in kind of a 101 motion, and you'll see how we bring this to life. And that'll be a good walkthrough for us. Okay, so the first thing I want to do is check routes, okay? Exhibit A, check your routes. Always make sure you check your routes first. Actually, Exhibit 0 would be check your network security groups and make sure that any network security groups you have that would affect traffic between VNets in this case are disabled. So I'll just do a quick run through on Spoke 3. In this case, it should be clean. So I don't have any NICs in this VNet in its NSG, and I don't have any subnets. So in this case, I'm clean. I don't have any NSGs that would preclude or step in the way of the firewall and make that firewall non-functional. Okay, so now we're going to check routes. Let that guy go. Okay. So I have a route here. I have all the necessary policy. I'm saying Spoke 3 default gateway go to firewall to match the hub go to firewall and to on-prem go to firewall. Now, I don't have it associated to a subnet, so let's do that. So I'm going to go to subnets. I'm going to go associate. I'm going to choose the virtual network that I want to draw in. In this case, it's my Spoke 3. In this case, I want my dev subnet where my machine is. Click OK. Okay, that's going to percolate away. Now let's go to the firewall and set a rule. Now these rules take a little while to populate, and that's because the control plane has to fan them out across a variety of backend nodes and button them up. So it's not a lightning fast operation today, so while the rule is populating, we might take a look at another example and come back to it. The Azure Firewall is fast, though, to deploy. I measured it last night. It was 4 minutes. So from start to finish to build this thing was about 3 minutes and 52 seconds, and that, to me, felt really good. That's a good story. Okay, now let's look at what this network rule would need to look like to allow this to happen. So we are just going to go build one. Add network rule collection. We'll call it jump box 2. Spoke 3. Okay, we'll give it another priority here. How about 2000? We're going to allow, and we'll just do some ICMP today. Okay, we're going to select ICMP as the protocol. The source address in this case, just to demonstrate all the different possibilities, we'll just make it the host address of the jump box itself, 10144/32, which is that host mask. The destination address will be in this case, the actual network of Spoke 3, which is 10.148.0/20. So I'll just open up the whole spoke, And for ICMP, we always do our destination port as star because, as we know, it's not a real transport layer protocol. It's a layer 3.5 layer protocol, so it doesn't understand port in the way TCP or UDP would. That's all just standard stuff. We're going to click add. Okay, now we're going to let that percolate. And while that happens, we will take another look at the lab here and discuss the application piece. So as I'd mentioned, we're going to use the application rule set to create a private endpoint for a storage blob. And then we're going to have on-prem hit it as a quote-unquote outbound motion. So we're going to kind of trick the Azure Firewall into thinking that on-prem is another private VNet, and it will sanitize that outbound for private PaaS access through service endpoints. So that's the play here. And let me show you kind of how I'm going to move that. What's happening here is I just have an Azure Storage Explorer instance downloaded on my Equinix desktop, and I have it bound to my lab account. And of course, it sees a variety of blobs that I have. So I have a blob here that I've whitelisted in the Azure Firewall called Briarwood, and it has a couple of containers inside, cats and more cats. And as you can see, I could refresh it, and it's actually working. So it's talking through the Azure Firewall privately and interacting with my blob because I've whitelisted the FQDN for the blob as a trusted destination. Now, the wrinkle is, wait a minute, the blob is a public endpoint. You're pointing your virtual machine to a private endpoint, but how is that FQDN being reconciled between the fact that the FQDN that Azure owns is public and the endpoint you're feeding the client as a destination is private? Well, that's all the trick of DNS, and that's a little sneaky motion that would need to be done either individually per workstation or systematically through an internal DNS motion to make this an enterprise-size solution. So, for example, what I've done here is gone into Etsy hosts on this Windows machine and overruled the actual private, rather the public address record that the internet and Microsoft would hand out for my blob in this case, and replaced it with the private address of the firewall. So that step is necessary if you're going to use FQDN as a mechanism to reach blob instances and PaaS instances privately through this topology. Now, how does that scale? Can I go into every workstation in my enterprise and manually edit the Etsy host file? Unlikely. That's very brittle. So better is to do what's called affectionately is DNS poisoning, where in your DNS server, which your on-prem DNS conditional forwarder, or the DNS infrastructure that you own, you kind of do have full control over what your DNS world looks like. So you could do a bunch of interesting, tricky things, like instead of resolving, star.core.windows.net or star.blob.core.windows.net to root hints in the internet, you would have a conditional forwarding rule to set it to the Azure Firewall. So basically, you would poison your own DNS in a trusted motion to get this to work. That's one way to do it. What's nice about the DNS poisoning solution and using the FQDN is that we do not have a certificate problem because the C name in the SSL or TLS certificate is that of the real FQDN. That's the FQDN that the tool is using. It's just that the A record is different. So when the SSL public key certificate comes across the wire and is inspected by the browser effectively, or the SSL kit in the browser, it compares the FQDN to the FQDN on the certificate, and we have a thumbs up. And this way I don't have a trusted error or any kind of problem. So the DNS poisoning solution is a little bit more elegant. Other things you could do to make this enterprise ready would be just to forgo DNS and point things to the bare IP of the Azure Firewall, or to just tell folks to ignore the certificate warning. You could also put a man in the middle in there, which basically would be like an F5 or an Nginx proxy that inserts its own certificate, and then use a private DNS name, your own FQDN, for that private endpoint as opposed to the public one. So there's a couple of different ways to go about it. So I wanted to talk through that before we march to the exercise. Okay, oh, wait, that's not the... I have the Inception man. I'm in a dream within a dream there. Okay, there we go. So back to the discussion about this new rule that we wrote. So let's go take a look at it again now that it's populated. All right, that looks good. I should be able to ping this workstation. Let me just double check that this workstation is, doing what it's supposed to do here. So here's my little dev box up in Spoke 3. It should be turned on. And we're going to go to networking and make sure that it has the private IP I expect it does. Yep, 10.149.1. Now that should be okay because I put the 48 as a /20, and we should be fine because the /20 would include the 49 block. So I think we should be good to go. So let's go back and see if we can ping that guy. Okay, that is me up in my, here I am in my jump box. Okay, so it's 49.4, right? Wah, wah, wah. The lab gods are not nice to me. Let me do one quick troubleshooting and then we'll move on. 10.149.4. All right, well, maybe I'll go back to my firewall and check a different rule. Do a little bit of troubleshooting together. Just tighten this up. Actually, you know what? If I save that, the firewall is going to crank away, and then it's going to take away from the example that I want to show you for the application thing. So let me bail out of that, and I'll show you the application piece, and then if we want to do a little live troubleshooting at the end, we kind of can. But I want to get to the good stuff. Okay, so in this application rule collection, anyway, we probably could get that working. I probably just have to tighten up my mask and do basic troubleshooting on, wait a minute, what source to what destination. But as you can see, creating ACLs is important. You have to look at the fine grained stuff. This is how an application security rule would look. I just give it a name. The source address in this case is on-prem through Equinix. You need HTTP or HTTPS, remember now at this time. As long as it's real HTTP or HTTPS, you can put custom ports in here. So if I have a web caching server or something that's doing HTTP on 8080, that's legit. I can do that in the Azure Firewall. Just so you know, it doesn't have to be 80 and 443. You can get away with custom ports, and you do that with the colon designation. That's fine. If you just put the standard HTTP and HTTPS, of course, is going to resolve to the well-known ports that we know and love, 80 and 443. Here's my target FQDN. All right, let's talk about how this is actually working today. How does it know that FQDN is the one that I'm sending, and how does it know to trust it, and then how does it know to forward it on? The Azure Firewall is doing outbound application security today using a feature of the TLS stack called SNI, or Server Name Indication. Server Name Indication has been around for, I don't know, 6 or 7 years now, but has gotten much more ubiquitous, and all modern browsers and stacks support it. What it does is there's two basic ways to implement it. The most popular one is an options field in the TLS SSL handshake that will alert the other side that SNI support is required or requested. The other side, if it supports it, will indicate true that it is. And what will happen is that the SSL handshake will forward the FQDN that it is sending for basically the host name that it wants to connect to, such that the other side can predict this and handle it with a wildcard certificate. So it's very helpful for virtual web hosting when I have, actually, it doesn't need a wildcard certificate. Excuse me, it's been a while since I talked through this. What I can do is, instead of having to pay a lot of money for VeriSign to sign a wildcard certificate like star.mydomain.com, which are rather expensive and bulky, what I can do is have an SSL policy on my backend that has a bunch of different certificates. The SNI request will say, this is the host name I want. Do you have a certificate that matches this host name? Now I can have all my individualized certificates, and I don't have to roll them up all up to wildcards, and I can be much more flexible with my host name assignment and management. These host names are SSL, these aren't, etc. And so the SSL stack will actually pay attention to that. Well, that's what the Azure Firewall is doing. It's not terminating SSL. It's not offering today the client its own self-signed certificate, or forwarding and caching the public key certificate of the secure resource behind it. It's just scraping the SNI conversation and looking at the host name there. Now, pros to this is that it makes it very fast and agile, right? Your performance is going to go up when you don't have to crack open TLS, SSL, decrypt it, look at the host header, re-encrypt and push. Now, sometime in the future, Yair has informed me that that is a forthcoming feature, this full SSL termination, and then there would be a knob to say, hey, for this application rule for this flow. I want to crack it open, and then that leads to more of a full layer 7 stack thing, and then all the features unfold from there. But today, we're at this nice kind of lean, mean, performant way of looking at FQDN, which is just to scrape that TLS handshake, get that SNI transaction, and look at the FQDN that's requested by the client, whitelisted, and forward it on to the FQDN in question. So when the Azure Firewall sees in the SNI request briarwood.blob.core.windows.net, it's going to basically resolve DNS. The DNS would point it to the public IP address that Azure has for that blob instance. It will then look at its routing table. The routing table is service endpoint enabled. The service endpoint enabled routing table will set a more specific path than, say, internet to that blob. It will leave via service endpoints. Azure will do the private to public translation, and the blob will be contacted. So that is exactly what's happening. So let's see that in motion, right? I mean, we kind of see it now with this thing, but you can see how I can go in here and just start uploading stuff. Because, remember, I fixed my host file, so I'm just going to put, I have an evil cat here. Check this guy out. I had to share this. This guy's awesome. Okay, there you go. All right, fun on a Friday. Sorry, guys. Us network guys are loopy. Okay, so there I am. It's going to queue it and upload it, and there it goes up to my blob through the Azure Firewall. So cool. All right, now, so boom, done. Pretty fast, right? Nice, crisp performance. Going over express route. Now, I've only whitelisted Briarwood. That means that if I have a nefarious target that's coming from on-prem, maybe I want to stop my workers from going to Facebook, or maybe I've been hacked and I have a malware rootkit and it wants to phone home or send traffic to some other FQDN or something, right? That's what this outbound security play is all about. I have a cached instance of this bad blob called Evil Briarwood. Now we see it because I bound my subscription to it and it shows as a management object. In real life, of course, you don't get this far because you're not caching a subscription. But to actually understand how this works, there is a blob container inside of the storage account, and see, I'm fried because I have not whitelisted it. The Azure Firewall is a default deny device, and it simply can't get to it. So in order to make this work, if I wanted Evil Briarwood to actually say, no, Evil Briarwood's this amazing hacker, he comes to work for me, he's getting away from the FBI, I give him a great deal and I allow him to come work for my organization, now he can have his blob and play with it, so I'm going to whitelist him. Okay, so let's see how we do that. Okay, here we go. How we would do that would be to go to the firewall. Okay, well, got to bail out of here, sorry guys. Okay, we are going to say new application rule collection. And then we'll talk about FQDN tags in a moment. Oh, you know what I'm going to do? I'm actually just going to edit the existing one. Let's just keep it clean. So, you know, any rule can have multiple entries, right? So it's not like you have to create one rule per each policy. In this case, this is my blob policy, so I'm just going to edit this rule right here. No, I don't want to delete it, guys. I'm going to open it up. I think what I have to do is fan open this one rule. There we go. Then click on that. All right. So I'm just going to say Evil Briarwood here. The source address would be that of my client. I do need to say HTTPS because that is what my blob is working. And I'm going to just do just the blob component. As we know, storage has many heads and faces. It has blobs and files and queues. In this case, I'm really being very specific. I'm just saying blob, as we can see by that blob domain in my FQDN. .blob.core.windows.net. Oh, typo.
You type.
How am I doing, Blaze? Is that good?
You got it.
Thank you, sir. Okay, save that out. I think I misspelled evil in my first rule, but whatever. As long as the FQDN is good. Okay, now this takes a little while to matriculate. As I mentioned, the Azure Firewall, being a VM scale set, has to go into each node, apply the rule, upload the configuration, make sure that the config was good. So right now, the rule application isn't lightning fast. It's not terribly long. It's, say, maybe 120 seconds or something. So that while that percolates, maybe what I'll do is go take a few questions, And then at the last, we'll just see that through my Storage Explorer that evil Briarwood blob will light up, and we'll throw a file in there. And that'll be kind of the end of the demo, just to say, hey, that whitelist works. That's, in principle, how we would manage that. So I'll go back. Let's see here if I can unmute folks. All right, we're live. Any questions or thoughts about what I've shown today?
Well, hey, Brian, this is Eric. Curious question. Have you ever convinced a customer to poison their DNS?
Yes. Yes, I have. This ability to have a PAS target be a private IP endpoint is very critical for enterprise, as it turns out, for a variety of reasons. What I've noticed in enterprise, understandably, is that they have 2 or 3 different sets of security policies based on where users are coming from, the kinds of workstations and equipment users are working, and the kinds of content that users are accessing. So it falls into what we at Microsoft have as kind of a low, medium, high business access or business information security policy, right? There are important classifications about what kind of information can be accessed from who and where, this conditional access. And a big part of that is, hey, for really high business impact stuff, I'm not invested in mobility and internet. There's a really key core component of my data that might be PCI compliant or FedRAMP compliant that's really only appropriate for private endpoints. And we at Microsoft understand and recognize that, and we are hard at work on a feature that will allow PAS endpoints to basically have their own private IP in the VNet, and then you can talk to them directly that way. And that solves a big part of that component, but I still think the Azure Firewall has a really important role to play there, because we're elevating the level above just a network conversation. We're actually looking at the application in the FQDN piece. And so now I can write my security policy not based on IP and routing, but on FQDN and what my applications are going to be doing. So I can fold my PAS story into that same application monitoring piece, outbound firewall piece, and have it all private. So that feels good to me. But that's a great question.
Yeah, I couldn't even begin to convince my customers to do that.
Oh, really? Yeah, I've done dozens of those.
Yeah,
I've done dozens. Yeah, I used to use Nginx, but now the Azure Firewall comes to the fore. It's
Okay.
yeah, it's been a very successful. Not everyone needs it, but there are cases where people say this is critical, and I helped design it, and it's very successful.
Yeah. Unfortunately, I support German customers, and so you apply the German beer purity laws to architecture, and they say that is not good.
Right.
We do not want that.
Right.
Done.
Well, yeah, we have to take it on a customer by customer basis.
Right.
You're absolutely right.
I mean, it's good to say
yeah.
this is how we're doing it. This is how other customers are doing. So maybe we could see that, but ultimately their expectation, of course, they expect us to do it yesterday, is to have private IPs and turn off the public IP.
That's right. And just as a friendly reminder to everyone, we are joined today. This conversation is totally fine, and I would have the conversation we're having in front of anyone. But just to keep us Microsoft people honest, we are joined here today by customers and partners, right? So
Sure.
We need to be mindful. But yeah, absolutely, you're right. It's not for everyone, but it's when it fits the bill, I think it fits it well. Okay. Any other questions?
Hi, Brian. This is Dermot here. When we're having conversations with customers, in its current, the way it is currently, the Azure Firewall, how would you think we position it with customers when they're looking at possibly other firewalls? They may have firewalls in place. They're looking at things for using MVAs, etc. Where do you see it fitting in the sort of the overall strategy when they're looking to secure their VNets and looking to set up their hybrid connectivity, that kind of stuff?
Absolute critical question, right? How does this Azure component play well with our friends in the marketplace, and how do we make value on that, and how do we play well with our peers in the industry? I I don't think the Azure Firewall, as we've seen today, is an end-to-end comprehensive solution, right? Today it's a V1 solution. It will gain elegance and capability, but it's not nearly as full-bore and sophisticated as a mature ecosystem platform, say all of our big boutique names that are in this space that are, layer 7 firewalls. I'll just prattle them off. We all know them, but, the Barracudas, the Palo Altos, the Checkpoints, the Fortinets, the Ciscos, even, F5 has an inbound, outbound firewall. So, and these devices are all in our marketplace, and customers love them and know them well. So, I would say that the Azure Firewall, what we like to do at Microsoft is maybe the 70-30 or 80-20 rule. When we see an opportunity to bring elegance in our platform for customers and help them with something like centralized management, agility, elastic scale, and security, we're going to. But we would never intrude on that specialized space, that 20% or 30% where these other companies who have been doing this stuff for decades and have large mature dev and sales teams are highly specialized. So, for example, look at our WAF product. It's a very fantastic, solid core offering WAF product. Is it something that gives you a tremendous amount of granular control and policy editing, and can I write, say, I rules in it, and do I have a tremendous amount of alerting and inspection? No, because that's not, we don't need to play in that space because we have this fantastic marketplace ecosystem that covers that. So I see the Azure Firewall as a solid table stakes, centralized elastic scale management solution. But if you're looking for more higher end kind of stuff that does more sophisticated IDS and IPS and SSL offload and gets into the packet and is able to do layer 7 traffic steering, then absolutely, it's we want to encourage folks to use partner solutions. So it's a Azure Firewall for the basic easy stuff, and then bring in the other stuff for the advanced stuff is my feeling.
Okay, thanks.
Yeah, you're welcome. So, gosh, we're almost out of time. Let me quickly show you guys a few other things here. Okay, so we've done the Evil Briarwood whitelist. Let's go back and see how my blob containers are up. Should be. Can I get to them? Oh, that's funny. So angry. Let's refresh. Okay, let's see what we get now. There we go. So I whitelisted evil cats. Now I can see evil cats. So fantastic. The demo guys have been nice to me today. And I would be remiss if I didn't show you a little bit about monitoring. So the Azure Firewall, and then we'll have to end there because we have just 60 seconds left, but let's just do the one more thing, everyone, has the ability to export a rich set of diagnostic and security data to 3 main places, which is basically the big play for a lot of our network appliances. I can put it out to a blob as a text file and scrape it and do stuff with it. I can put it out to an event hub for a RESTful interface, and I can put it out to log analytics. And let's take a look at what that looks like. Now, if you go to the Azure FAQ solution, there's a really great link in here to tutorial, monitor Azure Firewall logs right there. That will give you the file that I use to download and generate this log analytic ability so that you don't have to do any of the heavy lifting. Basically, the Yaris team has done it for us, so it's really nice. So I'm going to go into my log analytics. I'm going to go to my log analytics dashboard. At least I thought I had a dashboard. Yeah, so here's my dashboard. I've already imported my firewall rules. Okay, I'm going to click on that. It sees my one firewall instance. So for each firewall, I would have a dashboard icon, and I get all this cool stuff. So here we go. Here's all the logging coming out of it. It shows the allowed URLs over time. It shows, see how many times Evil Briarwood was denied until I whitelisted it. So I can dive into that and get more heuristics on that for security purposes. So it's going to show me a deeper aspect on that. And I can go in and check that out. So the diagnostics part is a really cool, nice cherry on top of the solution. So, well, guys and ladies and gentlemen, we're out of time. It's been a lot of fun today. Sorry that some of the folks didn't get the same screen sharing experience. Thanks as always for coming to Microsoft Networking Academy. It's a pleasure to have you all. in 2 weeks, we will be bringing in some partners and talking about Azure WAN, and Jamie Schmidtke will be having the con for that one. So I wish everyone a safe and happy weekend, and enjoy the rest of your afternoon. Thank you so much.
Thank you.
Thanks.